Hello everyone, welcome to my programming club. Today we will be solving another daily lead code challenge, and the challenge name is Earth in a 2D matrix. So you are given a n cross n integer matrix with following properties. Each row in this matrix is sorted in ascending order. So as you can see, 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60 all are in ascending order row wise. The first integer of each row is greater than the last integer of the previous row. So what does the problem statement mean by this property is it means that let's say this is the last element of zeroth row since it's a zero based indexing. So this first integer of the following row will be smaller than this. So what we can do is we can pick these rows one by one. Let's say we pick the first row, the second row, the resulting linear structure that will be formed from these rows by joining end of one row to the start of the subsequent row. We will form a linear structure or say a linear array which is in sorted order. This whole linear structure is in sorted order. Now what does the problem statement further says? Given an integer target, you have to return true if that target is in the matrix. Otherwise, you have to return false, and you have to write the solution in O of log m into n time complexity. M here is the number of rows, n here is the number of columns. In total, there will be m cross n elements. These elements can be arranged in this linear structure. So we have to find a solution. We are given a number target. We have to tell whether this exists in this linear structure or it does not exist in this linear structure. So what we have to do is we have to form such a solution whose time complexity is O log m cross n. Since you can observe that these are number of elements in this linear structure, are nothing but m cross n. Now let's say if I ask you, now let's number these elements. Since it is a zero based indexing, I am starting from 0. Now I have numbered these elements. Uh, if I ask you Let's say I ask you, what is the 11th element, elements, row and column in matrix. So 11th element here is nothing but the 12th element. Since it is a zero based indexing, we are starting from zero, so it is indeed 12th element only. But here, according to zero based indexing, I am asking you, what will be the row and column, what will be the coordinates of the this 11th number coordinates. Pardon me if some spelling is incorrect. I hope it is not affecting your understanding of the problem. Now, if I ask you coordinates, how will you give me the coordinates? Now, you can observe that in a row there are column number of elements, which is nothing but equal to n. So in each row you are having n elements. So if you divide the this element number, which element number's coordinate was asked from you? Element number 11's coordinate, which is actually 12th element. This is according to the zero based indexing. So what you will do is, let me quickly clear the board. Yeah, what you will do is, you know that there are n elements in a row, which is nothing but equal to number of columns. Let's call this as false. And if I ask you what will be the row number, you will simply be returning the element number divided by columns, because uh, it will give you the number of complete columns that have already been used to form this number. So if you divide number of columns, which is here nothing but 4, 11 divided by 4, it will give you 2. So 2 columns have been used already. What I mean to say is, for each column of 4 size, which sum up to 8, have already been used in making 11, and the column at which we will be situated, the coordinates of this 11th element will be situated will be second column according to the zero based indexing. So it will be this column. It will be this row. So it will give us row coordinate r. Let's call it r. And what will give us the column coordinate? It, but if we divide the element number, if we take a reminder of the element number with the number of columns, let's call this false. Now 11 remainder with 4 will be 3. So it will be at the 2 comma 3 coordinate. These coordinates are according to zero based indexing, and this element number was also according to zero based indexing. Now, since the structure is sorted, you can apply binary search. You will generate the element numbers. What you will be generating? Let me clear the board again. You will be generating element numbers. So let me take a new slide only. Then you will be able to understand it in a clear way. Yeah, let's begin from here. Uh, you can use binary search since this linear structure is sorted. What will binary search be searching for? Element numbers. Are nothing but indices of the linear structure. And this indices will range from 0 to m cross n minus 1. Now you may ask, why can't we take from 1 to m cross n? Because, for example, let's say you are given this input. This is the given matrix, and your target is, let's say, 2, or even if it's 1, then you will generate the coordinates R, C. Since the number of columns is 1, so column will be equal to 1. So if you went to generate this row, then let's say your indices are your range is from 0 to 1 to 1. Since m cross 1 will be also 1, and this 1 is also 1. So left in binary search, those of you who are not familiar with binaries, and it's a new topic for you. I will be including a article of a link of article which you can explore, and then you can come back to this part. Let's call the left part of the range 1, and m cross n in this case will be nothing but 1. Let's call this right end of the range, and it will be 1. We will take middle of these two, which will be nothing but 1 plus 1 divided by 2, and it will be 1. So this will be the element number we are proposing, element number or index in linear structure. Let's call it ls. So it will be the element number. If you generate a row coordinate from this or x coordinate, you will get 1 divided by number of columns 1, which is 1. And for column coordinate or y coordinate, you will be dividing this element number. You will be taking remainder of this element number with the columns, number of columns. It will be 1, so it will be 0. Now the column is correct. Okay, this is the 0th column indeed, but the row which is 1 is not correct. It will give you out of index out of bound. Index out of bound error. So what you have to do is you have to take range from 0 to m cross n minus 1, so that m cross n never reaches equal to this number of columns. In that case, you may get an index out of bound exception. So I hope you are able to understand why I have taken this particular range. Why not from 1 to m cross n? Now we will be applying binary search over this range. What we will be generating? We will be generating this element numbers, which are nothing but the indices in this linear structure. This linear structure is a hypothetical construct that I have made to make you understand the logic of the uh, problem solution. So yeah, this is what we will be generating, and according to the element number, we will be generating its coordinates. And based upon whether the element at the coordinates is equal to target, if it happens to be equal to target, we will return true. If it's less than target, let's say it's less than target, then we will be increasing our we will be decreasing our search space to half, and it will be nothing but let's call the element number generated to be mid position. It will be from mid position plus 1. Since mid position is lesser than the target, it is very well understood that since the linear structure is in sorted form, so the element greater than the target or mid position will be at the index mid position plus 1. So your range will be mid position plus 1 to right. And if and so will and similar case for the if the target is smaller than the mid position, then you will shift your right hand, and it will be from left to mid position minus 1. I hope you are able to understand. If you are not still not familiar with the binary search, I will highly recommend you to go to the article link that I have shared you for binary search. It will be provided in the description of the video, so you can explore that article. And now let's quickly move to the coding part of the problem. So these are the number of rows, these are the number of columns in the matrix, and this denotes the range that we will be searching for. We will be searching for the element number in the range left to right, and we will use binary search for that purpose. So we are using a standard binary search, and accordingly we are shifting our range values, and if we hit the target, then we'll return true. And at last, we if we are not successful in uh, finding the number in that given range, then we will return false. This is nothing but we generating coordinates, the mid position of the element number in the linear structure. Which linear structure I am referring to? This linear structure, which can be formed by attaching end of one row to the start of the subsequent row, and it will be in the sorted form. So this is the linear structure. It will be in sorted form. We generating the coordinates of element number in the linear structure. Coordinates of element number in the linear structure where these coordinates will be present. These coordinates the matrix given. So we are generating the coordinates, and accordingly we will check if these coordinates, at these coordinates we are having the number, then we'll return true. And if it's not the case, the number at this coordinate is lesser than the target, then we will be shifting our range. We will be checking for a greater numbers, so we will shift our range from mid position +1 to right. And if that's if it is the opposite case, then we will shift our right hand to mid position -1. So this is a standard binary search. I hope you are able to understand the solution of the problem, and if you are still having any doubts, please ask them in the comment section. I will be more than happy to answer them. Thank you for watching. Thanks.